Solid. Properties of solid. Solids are arranged closely together and definite order, only vibrate and rotate about fixed position, maintain its own shape and size, cannot be compressed and unable to flow. Melting is the process of solid changes to liquid. When solid heated, the particles gain kinetic energy and vibrate faster. At certain temperature, the particles have enough kinetic energy to break free of their fixed position. So that's how it becomes liquid. Freezing is the process of liquid changes to solid. When liquid cooled, the particles lose kinetic energy and move more slowly. Intermolecular forces become stronger because when it moves slowly, the particles become closer to each other. So intermolecular forces become stronger and particles become fixed in position. As more and more of particles settle into a relatively fixed position, the substance gains a shape of its own and becomes a solid. Sublimation is the process of solid changes directly to gas without become liquid first. So from solid directly to gas. When a substance sublimes, molecules leave the surface of the solid where they are held by less tightly than the interior. The combination of intermolecular attractions and atmospheric pressure is not great enough to keep the particles near to one another when they leave solid state, so it straight away becomes gas. Deposition is a process of gas changes directly to solid without becoming a liquid first. For example, when iodine vapor comes in contact with a cold surface, it deposits iodine crystal, so this is in solid form. At ordinary atmospheric pressure, solid iodine sublimes. Structural features of solid. There are two features of solid that we are going to focus here: crystalline solid and amorphous solid. Crystalline solid is well-defined shape. Particles are in orderly arrangement, for example, metal, salt, and diamond. Amorphous solid is poorly defined shape, lack in orderly arrangement of the particles, for example, charcoal, rubber, and gas. Note that both of these kind of solids are closely to each other. Types of crystalline solid: metallic, ionic, molecular covalent, giant covalent. So both of these two covalent bond, this one molecular covalent, this one giant covalent. Extensive network of giant covalent. Metallic solid, lattice points occupied by metal atoms, so these positively charged metal atoms. We know that metallic bond held together by a strong metallic bond, C of delocalized electrons. So metallic solid held together by strong metallic bond. We know that metallic bond is a form of C of delocalized electrons. So all these electrons are mobile. Soft to hard, low to very high melting point, depends on the type of the metals. Good conductor of heat and electricity. Ionic solid, lattice points occupied by cations and anion. So for example, here we have sodium chloride. This chloride anions, and this is the sodium cations. These cations and anions held together by strong electrostatic attraction, because both of them are different charge, negatively charged and positively charged, so held together by strong electrostatic attraction. Ionic solid is hard, brittle, high melting point, but poor conductor of heat and electricity in solid state. But in molten state, or in aqueous solution, it can conduct heat and electricity due to the free moving ions. Next, molecular covalent. Example, ice and octasulfur. Molecular covalent, lattice points occupied by molecules. So this water molecules, lattice point, it's a lattice point. All these molecules held together by intermolecular forces, fairly soft, low to moderate melting point, poor conductor of heat and electricity because there's no free mobile ion. Next, giant covalent, held together by strong covalent link and forms extensive network. So this is also covalent bond held together by strong covalent link and forms extensive network. Very hot, very high melting point, usually poor conductor of heat and electricity. So this is an example of giant covalent for diamond structure, graphite made up of carbon and silica.